Hello everyone. The last class we already discussed what is combination logic circuits, what are the examples for combination logic circuits. In the last class we already discussed half adder, full adder, half adder, full adder. Now we are going to discuss subtractors, half subtractor, full subtractor. Okay. Subtractors. So again the subtractors two types. One is the half subtractor and another one is the full subtractor. Okay. I think we already know subtraction. Subtractor means subtractions. So half means the number of variables representation. So here it is two variables, means two inputs. Here it is three variable. That variable is nothing but three inputs. Two input level, three input level. So what is the subtraction? How to subtract the number from one number to another number? That means small number to large number to small number. Okay. So before going to that, what is designing procedure? What are the steps to design a combination logic circuits that we are discussing? Combination logic circuit. First step is block diagram representation. Now we are going to discuss half subtractor. Half subtractor. So in that half subtractors, first combination logic circuit, first step is the block diagram representation. So in that block diagram we need to mention number of inputs and number of outputs. So here two variables, the number of inputs are the two inputs. Okay. So here I mentioned two inputs, let it be considered x and y. Here subtracted the generating outputs. So this is the name of the combination logic circuit is half subtractor. So in general, sum xy is the inputs for adder. The generating outputs are the sum and carry. Here half subtractor, xy is the input. In 1's complement and 2's complement we already discussed how to subtract the binary numbers. Okay. So it generates the carry, add to the next, that is addition. If it is so in subtraction, if it is in high small number to big number, means should take the borrow from the previous bit. So here the generating outputs are the borrow, so that is borrow, and next one is the subtraction, that is nothing but difference. Okay, generating outputs borrow and difference. In adder, sum and carry. Here the inputs are the x and y. Okay. So first step is the block diagram representation. Second step is the truth table. Truth table. So in the truth table we have to mention inputs and output relation. So here the inputs are the x and y. Inputs are x, y, that is two input level. So what are the possible combinations? 0, 0, 0, 1, 1, 0 and 1, 1. 1, 0 and 1, 1. Okay. Next, here difference and borrow are the outputs. Outputs are the difference and borrow. So I will explain what is the borrow representation, what is the difference representation. So here 0 minus 0, 0 minus 0, that means difference is 0, the borrow is also 0. Here 0 minus 1, so it's a small number, subtract the big number from the small number, you should take the borrow. So that's why I am considering 0 minus 1. Here simply blindly we can identify 0 minus 1, that minus indicates, it generates the minus, negative indicates borrow and 1 indicates difference. Yeah. Here 0 minus 1, that is minus 1, that minus indicate borrow, 1 indicate difference. Okay. Like say 1 minus 0, here 1 only, 1 minus 0, 1 only. So there is no negative, means here there is no borrow. Again 1 minus 1, 0 is the difference, borrow is also 0. Borrow different, borrow 0, both are the 0, 0, because here 1 minus 1, 0. Here there is no negative and there is no 1. That's why it can represent 0, 0. Okay. Next, after this truth table, what is the next step? After truth table, third step is the find out the output expression using K-map. Okay, K-map. here two variable came, because here inputs are the only two inputs. So that's why here what we have to mention. So what is the sum inputs, what is the carry out inputs, difference and borrow. So difference inputs is, so when it is goes to high, this is the 0th position, this is the 1 position, 2 and 3 according to their binary numbers. Okay, when it is goes to high, these two situations, that is a 1 comma difference is 1 comma 2, difference is 1 comma 2. And what about borrow? That borrow is summation m of, so when it is goes to high, only in this case, that is 1 only. Okay, so now we have to find out the output expression using K-map. So the difference K-map is, this is the difference K-map. Here variables are the x and y, here 0 1, here 0 1 according to the K-map. So this is a 1 place, this is a 2 place, there is no adjacent terms, we can write it individual. So it indicates row and column, row indication x bar, column indication y. Here again there is no adjacent term, row and column representation, that row represents x, column represents y, so that 0 indicates y bar. Okay, so here the difference expression is x y bar plus x bar y. So okay, it is in the form of x exclusive of y. Okay, now so this is the difference expression. So what about borrow? So the borrow x y, here 0 1 0 1, so 1, only 1 is the min term, that means that output is high, only one case. So what is the expression here? Here x bar, here y, single row single column representation. Okay, so then the borrow expression is, borrow is equal to x bar y. Okay, so this is second one, this is the third step. Next final step is the fourth step is the combinational logic circuit. So last step, combinational logic circuit. So here it is. So this difference and borrow in a single circuits, because it is a total full of subtractors. So what is the difference expression? XOR operation, both inputs exclusive OR operation. So that exclusive OR operation can represent it as x y is the inputs. So directly we can get XOR operation. So this is the XOR logic gate symbol representation. So here it is, difference is equal, we can write it directly, x exclusive of y, that is equal to x y bar plus x bar y. Like same, carry is x bar y. So this is only direct x, that we have to connect complement gate or NOT gate. So we can create node, means that is connected internally. Here x bar into y. So this is the x bar, this is the y. You can connect x bar into means AND logic. So here the output is x bar y, that is equal to borrow. So this is the logic diagram, combination logic circuit for the OFF subtractor. Okay, so this is the truth table representation for the OFF subtractor. So whether it is in full subtractor, we can change the input variables, that means x, y, z. There is no change in that output, only difference and borrow. It's like same as full adder. Okay, now we'll see full subtractor. Topic name is full subtractor. Here, like say the number of inputs representation for the block diagram. First step is block diagram. So in that block diagram we need to mention how many inputs. So let it be considered here full means 3 input level x, y, z. Here the generating outputs are the difference and borrow. The name of the device is full subtractor. Okay. So next step is the truth table representation. What is the input and output relation? So x, y, z. Next one is the difference and borrow. So XYZ 3 inputs, combination 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So we can represent it, that is it's a 0 number, 1 binary number, 2 binary number, 3. That means in 3-bit combination start from 0 and end with 7. Okay, so what is the output? So the difference is subtraction of each and every number. 0 minus 0 0 0 minus 0, that means difference is 0, borrow is also 0. Borrow means it indicates negative sign, so that's why you can hear 0 minus 0 0 0 minus 1. First these two relation, next these two relation, that result and next input bit, these two result and next input bit, like same 0 0 0 0 minus 1, that is minus 1. So minus 1 means minus indicate borrow, 1 indicates difference, like same 0 minus 1 minus 1, minus generated means that borrow is 1. So borrow 1 mentioned means that negative is converted into positive. Next 1 minus 0, that means 1. Okay, next here 0 minus 1, minus generated, then the borrow is represented as 1. So 1 minus 1, that is 0. Next 1 minus 0, 1 only. Again 1 minus 0, 1 only. The difference is 1, borrow is 0. 1 minus 0, 1. Again 1 minus 1, 0 0 0. 1 minus 1, 0 0 minus 0 0 0. 1 minus 1, 0. These two 0 0 minus 1, that is equal to minus 1. That minus indicates borrow, 1 indicates difference. Minus indicates borrow, 1 indicates difference. Next you have to represent what are the min terms for the difference and borrow. Okay, so now the difference min terms, when it goes to high, the difference is this one, this one, this one and this one. So for this case 1 2 4 7, 1 2 4 7, 1 2 4 7. Next borrow, when it goes to high, this one, this one, this one and this one. Okay, borrow, that means 1 2 3 7, 1 2 3 7. Okay, so here 0 to 7, the number of inputs are 3 inputs, so we can consider as 3 input 3 variable K map. You can consider 3 variable K map. So here the first expression is difference expression. So here 3 variable K map, we can represent it as x here, yz here, single variable, what are the possible combinations, 0 and 1. Here yz 0 0 0 1 1 1 1 0. Here these two interchange regarding only 1 bit change term. Okay, so what are the terms? 1 2 4 7, these are the places 0 1 2 3 4 5 6 7, 0 1 3 2 4 5 7 6. So according to that, what are the given positions? That means these positions 1 2 4 7, the difference is 1 2 4 7. Here is the 1, this is the 2, next 4, next one is 7. Okay, 1 2 4 7. Okay, so here it is, there is no adjacent term, you can write it individual, so it's like same as the full adder carry, full adder sum. So here it indicates single row, single column, that indicates 0 0 1, 0 indicates x bar, 0 1 indicates y bar z, 0 1 indicates y bar z. Next this box indicates single row, single column, single row that indicated as x bar and 1 0 indicated as y z bar. Okay, next one is this box indicates row representation is x, column representation is y bar z bar. Okay, next one is this box indicates column, row is x, column is yz. Okay, the total expression, the difference expression is difference is equal to x bar y bar z plus x bar y z bar plus, because it's considered as a min terms, we can write it sum of products. Okay, so from these two just take common, x bar is a common, y bar z plus y z bar for the representation of the special gates. From these two x is the common, y bar z plus y z. Here x bar into y exclusive OR of z, that means XOR operation plus x into, this is the XNOR operation, that means y x new XNOR. Okay, what is the relation XR and XNOR? XNOR is equal to XR complement, XR is equal to XNOR complement. So I can write it as y exclusive of z plus x into y exclusive of z whole bar. So it is in the form of a bar b plus a b bar, that is again it is in the a exclusive of by b, a exclusive of b. Here b means y exclusive of z, a means x. So finally the difference expression is, what is the difference expression? X exclusive of y exclusive of z. It's the difference expression. Next, borrow. Okay, just I converted into special gates operation. So that is a borrow indication. Borrow means here x, y, z. Here what are the borrow indications? 0 0 0 1 1 1 1 0 0 1 1 2 4 7. Here the min terms are the 1 2 3 7. These are 1 2 3 7 places. Okay, now just I am considering these two mapping, again these two mapping, again these two mapping. For this case, these two mapping means this expression, it indicates single row 2 columns, single rows x bar representation, 2 columns common term 0 1 1 1. So that is 1, second position is common, so that's why we can consider second position is z. In SOP representation is without 1 means without complement, that is z. Next, these two combination, these two, it indicates x bar, here the common term is y. Okay, next these two, directly it is a column representation, that is a yz, yz. Now the borrow expression is x bar y plus x bar z plus yz, x bar y plus x bar z plus x. So next one is the combinational logic circuit diagram. Okay, combinational logic circuit diagram. Okay, so first XOR operation. So fourth one is a CLC, combinational logic diagram. So first x exclusive of y exclusive of z. So first I am giving x, it's like same full adder sum expression, x y, x exclusive of y. Next exclusive of z, again we need to give from this, here z, that means x exclusive of y exclusive of z. Okay, next one is borrow representation. Both sum, difference and borrow should be designed in only single circuit diagram, because it is a combination logic circuit for the full subtractor. So here it is x bar into y. So this is the x, the output of complement is x bar. Next y, these two multiplication, then we'll get x bar into y. Okay, so first product term is over. Next one is x bar into z. So we have to consider from here, create node, that node indicates it is connected internally. Okay, here x bar, next with the multiplication of z, x bar into z. So z we have to consider from here, these two end logic, then we'll get the x bar z. One more product term is yz. Here this is a y, this is a z. Okay, so summation of these three product terms, so then we'll get borrow expression. This is a borrow. Here output is yz. That means it's a OR logic. That OR logic is a combination of x bar y, x bar z, yz. That means x bar y plus x bar z plus yz, for that is a borrow expression. So this is the combination logic circuit diagram for the full subtractor. Okay, clear? 3 inputs, that is a representation of the full subtractor. So we have to define the difference and borrow. According to the difference and borrow, we can generate the output expressions. Based on that output expression, we can design the combination logic circuit for the full subtractor. Okay, so thank you.